Hello everyone, welcome back to my YouTube channel. So this is a new video lecture series on the module number 4. Okay, so module number 4 is having three subtopics or subunits to discuss, as you can see from the syllabus over here. So first part is BGT part, second part is feedback amplifiers part, and the third part is oscillators. Right? So BGT later, now this video lecture will start with the feedback amplifiers. So that is what is done over here. So module number 4 will be discussing what feedback amplifiers, and the here is principle of operation of feedback amplifiers. So let us go into the details of this. Okay, what is feedback? Why it is used? All those things you are supposed to know initially. So let us understand what is feedback. Let us see its definition. The amplifier in which part of output is sampled and fed back to the input of the amplifier is called as feedback amplifier. What is trying to say is some part of output, whatever output signal is coming, some part of output signal is taken. It is sampled. Sampled means sliced out, and it is taken, and that is fed back to the input side of the amplifier. So such an amplifier is called as feedback amplifier. Therefore, at the input we have two signals now. One is the main input signal that is coming in, and the other is a part of output signal which is fed back. Right? Okay. So there are let us see its types. Okay. So both the types, both these signals may be in phase or out of phase. Both these signals means the main input signal and the feedback signal, they may be in phase or out of phase. Okay. When input signal and a part of output signal are in phase, when input and the feedback signal both are in phase, then such a feedback is called as positive feedback. On the other hand, when they are out of phase, such a feedback signal, such a type of feedback is called as negative feedback. So let's try to understand this positive and negative feedback with the help of the figures, right? So this is figure A showing you positive feedbacks. So we have an amplifier of amp over here, right? And from the feedback network, we are giving that to the input side. Right? You just see this is the input voltage V in. Just see here, this is the input voltage, and this is the phase that is going from 0 to maximum. It is coming back and it is going to negative and it is becoming 0. That is, they just observe this phase and you just observe the feedback signal phase. So it is also initially starting from 0, it is going up and it is coming down. So this signal and this signal are having same phase. Right? Same phase means there is no any phase shifting. So same phase is there. So what happens is this signal, this amplitude will get added with this amplitude. So you'll have a little increased amplitude over here. Okay. So that is what is called as positive feedback, and we'll be having, if input is this much and we are giving that input to the amplifier, and basic operation of amplifier is to amplify the input signal. So applied input signal is amplified and amplified version of the output is produced. Okay, this is what is called as positive feedback amplifier. Simultaneously, we shall see negative feedback also. This figure B is showing you negative feedback. In this also part of output is taken, amplified and taken and given to feedback network, and you just observe the phase over here. So this is the input phase, input signal, and this is the feedback signal. You just observe the phase. So input signal is going from 0 to max in the 0 to max in positive direction in the first half cycle. In the feedback signal, it is going from 0 to maximum in the negative half cycle. So you can observe over here there is a phase shift between this input and feedback signal. As a result, what happens is whatever amplitude is there in the first half of the input waveform is subtracted with the whatever first half cycle is there in the negative feedback. The meaning is the amplitude is reduced. Fine. Whatever amplitude, input amplitude is having, input voltage is having amplitude, that amplitude is little bit reduced, and such a signal is given to the op amp, and we'll be getting the output. Compared to positive feedback, output signal amplitude will be lesser over here. Okay, this is what is about positive feedback and negative feedback. So let us see the differences. What are the differences between positive and negative feedback? Fine. You might get a question in the main exam. Compare the positive and negative feedback. So that is the table is given over here. So we have a parameter. We have positive feedback and we have negative feedback as a head here. So first parameter is phase shift between the feedback signal and the input signal. What is the phase shift between feedback and input signal? That parameter will be discussing with respect to positive and negative feedback. So in the positive feedback, there is no phase change. No phase change means what you can say 0 degrees. And we can also call it as 360 degree also. Okay, 0 or 360. We take a negative feedback, there is a phase inversion, right? Phase inversion of 180 degrees observed. This is the first difference. Second point is feedback signal and input signal are in phase. Just now we say that the degree phase change is 0 degree phase change means what I can say is input signal and output signal are in phase, right? Whereas in negative feedback signal we are saying that 1 degree phase shift is there. Its meaning is the input signal and the feedback signal are out of phase. They are not in phase, they are out of phase. Let us go to third parameter, that is input voltage. So in case of positive feedback, of input voltage increases. Why it increases is input to signal V in and feedback signal, if they are in same phase, they will get added with each other. When they get added with each other, the input signal that is being applied to the amplifier is increased. Okay. Whereas in negative feedback, because of a phase reversal of the feedback signal, the input signal amplitude is subtracted by the feedback signal amplitude. So because of that, what happens is input voltage decreases. Right? Now let us consider output voltage part. As the input is increased, obviously output will also increase. In the negative feedback, as input is decreased, output will also definitely decrease. Next parameter is voltage gain. If input is more, output is more, then obviously the voltage gain will be more, right? And whereas in negative feedback, input is less, hence output is also less. Therefore, voltage gain is also less. Let's consider distortion. In the positive feedback, distortion is more, whereas negative feedback, distortion is less. Now consider stability. It is very important part. Here with the positive feedback, stability decreases. Okay, whereas negative feedback, stability increases. Why it decreases, why it increases, we shall see it in the further topics. The last part is it is the positive feedback signal is used to design oscillators. Okay, it is used to design oscillators to generate the oscillations, sine waves or cosine waves, and schematic triggers. Whereas negative feedback amplifiers are used mainly in case of amplifiers. Okay, so this is all about the first topic to be discussed. That is, this is all about the first topic to be discussed. That is principle of operation of feedback amplifiers. Thank you.